Alright students, welcome to chapter 17. This is our final lecture for the semester. Woohoo! So this lecture is all about learning about chi-square analysis, which is one type of non-parametric statistic. So here are our objectives. The first thing is to know what parametric and non-parametric statistics are and what the analogous tests are. So if we have one type of test that's parametric, what is the non-parametric test that accompanies that or is similar to that type of test? We'll also know how to create and interpret contingency tables, also known as crosstabs and SPSS. Then learning how to apply the 5 steps of hypothesis testing for chi-square analysis. And then how do we calculate expected counts and residuals? And then lastly, how do we look at SPSS output and interpret that output so that we can determine our test statistic, make a decision, and state our conclusions? So let's start off with what parametric and non-parametric statistics are. So the first thing you want to think about parametric statistics. The base word of that is parameters. So think about what are parameters, right? These are numbers that we know estimate the population. And whenever working with parametric statistics, the data that we're usually working with is interval and ratio. It's some quantitative value. And so some of the assumptions that we have and that we've kind of talked about in some of the previous tests are that our distributions are normally distributed, that we see a nice normal distribution curve, because underneath that curve we can go ahead and approximate proportions and probabilities. We know that with parametric statistics we also have random and independent sampling so that every single person or case in our samples have an equal chance of being selected into that sample. And when it comes to parametric statistics, one of the things is that we usually have to have relatively large sample sizes, those of at least 30 individuals in your sample, so that we can make some generalizabilities from our sample to our population, right? Thinking about the entire purpose of inferential statistics is that can we infer what we learn and what we find within a sample of people and try to infer that and generalize that to the larger population. And we have some other assumptions that go along with parametric statistics. One of those is homogeneity of variances, which we know is related to independent samples t-tests, right? That we want both of the variances in both of our groups to be equal, because the more that they're equal, that we can really say that if there are significant differences, it's due to the independent variable. But we also are just going to learn about non-parametric statistics, which is what this chapter is all about. One type that we're going to learn is the chi-square analysis. And so when working with non-parametric statistics, this is when the data that we're working with in terms of our dependent variable and our outcomes is nominal or ordinal in nature. So we have qualitative data. And because we have nominal ordinal data, we don't really assume normal distributions. Right? When you think about the normal distribution curve, that all has to do with means and standard deviations. Well, with non-parametric statistics, we don't necessarily have to assume that we have a normal distribution. So thus we can actually have data that's skewed, maybe have some positive or negative kurtosis, right? So because we don't have the normal distribution curve, then we can really work with non-parametric statistics to be able to infer and generalize our results. And one of the big things about non-parametric statistics is that these are really based on observations, based upon frequencies, counts, percentages. Whereas when we're working with parametric statistics, this is when we're working with quantities, quantitative variables, right? Age, time, weight. There's real numbers to this, so we can calculate a mean and standard deviation. But when it comes to non-parametric statistics, we really don't really work with means too much. We're working with observations, with counts. And the last thing that we'll talk about in terms of non-parametric statistics and how that differs from parametric statistics is that non-parametric statistics are less powerful in finding significance. It's harder for us to find significance. If we were going to do two analyses on the exact same variables of the exact same sample, and we did one parametric statistical test and we did a non-parametric statistical test, we'll end up seeing that the non-parametric test will sometimes give us non-significant results, whereas if we ran a parametric statistical test, then we would see significance. So one thing I provided you guys with is a handout from the Mayo Clinic, which is a highly esteemed medical clinic in Minnesota. And it really talks about a little bit more detail about the difference between parametric and non-parametric statistics that the textbook does not really go into further detail on. So I encourage you guys to read that. It'll help you in terms of understanding the differences between parametric and non-parametric statistics. So let's take a look at comparing parametric statistics and non-parametric statistics. So when we're comparing two measurements from two independent groups, can you recall what test that is that we're doing? We've learned this particular test. When we're comparing two measurements from two different groups. Do you remember what that is? This is when we're doing an independent samples t-test. We're comparing two means from two separate independent groups. Well, the non-parametric test that's analogous to the independent samples t-test is the Wilcoxon rank sum test. And so you'll also see some other people use the Mann-Whitney U test. So these are similar tests that we would use if our data is not necessarily normally distributed, or if we're looking at observations instead of really looking at means and standard deviations. What about if we're looking at two different measurements from just one sample? Can you recall what test it is that we do? Well, this is when we're doing a dependent or paired samples t-test. And the analogous non-parametric statistical test to the dependent or paired samples t-test is the Wilcoxon sign rank test. When we're comparing three different groups on three different measurements, what test are we doing? What parametric test are we doing? This is our ANOVA test. And so the non-parametric test to the ANOVA is the Kruskal-Wallis test. And if we want to look at the relationship between two variables, what test is that? This is when we're doing a Pearson's correlation coefficient. So do you recall, we actually learned what the non-parametric test for Pearson's correlation coefficient is. Think about what tests do we do when we have ordinal variables. Spearman's rank correlation coefficient. So what we see here is similar to what you see in the parametric versus non-parametric handout. Make sure you guys know what the non-parametric test is that is analogous to the parametric test. We're not going to go in too far detail in terms of looking at these analyses per se in terms of SPSS output, but I want you guys to know what the non-parametric test is that's equivalent to the parametric test.